But here's what I was saying earlier. Here's the not so obvious thing about this situation that also makes me think. So let's evolve it and see what we got. All right. Let's say this is our impression cylinder. All right? Impression cylinder. And then this is our plate cylinder. Plate cylinder. Okay? And let's focus only on the print diameter. Diameters, okay? So now this here, there's no changes taking place on the impression cylinder except the material now, instead of being like maybe that thick, is now thicker, okay? So as a result, you know, my friend is wanting to see, can I reduce the diameter here to accommodate that thicker material, okay? All right, that's fine. So now we have that material here, and now let's take here, and I'm going to exaggerate it, but now I'm going to come in here to the new diameter. Now, by reducing this diameter, I've backed it away. Okay, that's fine. But here's the other thing I've done. This cylinder here is locked in by a gear. Okay? It's fixed. So now, let's see what happens when we do one revolution. If this thing goes around, let's say the substrate is going that way, and so things are going this way. If you start here, right here, and this is a 12-inch repeat cylinder, normally, right? That means that when this does one revolution, equals 12 inches. Okay? Now, because this is geared and everything like that, that's going to continue to do the same revolutionary speed. We're just talking about decreasing the diameter. But you see, for that same revolution under the normal circumstance, where we would have been traveling 12 inches, we're actually going to be traveling less than 12 inches. By how much? That 0.10 thickness that we went down times pi, that's how much? 0.01 times 3.1416 equals 0.31 0.031 inches. So at the lower diameter, where we're taking away 5 thousandths thickness of tape that make a difference of 10 thousandths to the diameter, well, that 10 thousandths difference to the diameter multiplied by pi tells us that it's 31 thousandths difference to the circumference. So if we take 12 inches, 12.000, and we take away 0.031 inches, what do we have? You gotta practice doing this old stuff. You know what? Let me use a calculator. How's that? 12 minus 0.031 equals 11.969. 11.969 inches. It's traveled. Now, that same revolution that would take it 12 inches is now going to take it 11.9 inches. But the material isn't slowing down, okay? The material is traveling at least 12 inches. So for every 12 inches this material travels, the plate travels only 11.69 inches. That tells me there's a little bit of slipping going on, okay? The material is going to be traveling slightly faster at the surface than the surface of the plate. So you're going to have a little bit of slurring, okay? So you have to ask yourself, is slurring going to be a problem I can live with to accommodate this thicker material? And then finally, just to add to it, by going up the further you go away from this cylinder here, maybe the faster the material goes. Depending on how this material is going through the web, that being thicker either affects it or it doesn't, and it probably doesn't, but it certainly doesn't make it go slower. So let's just assume it's traveling at the same speed, because now rather than going 12 inches for every RPM, and now we're going 11 for every revolution, now we're going 11.969, we have a little bit of slippage. How much of a slippage? Let's find out. 11.969 divided by 12. We have like a 2.5% difference. So the speed of the surface of the plate has slowed down relative to the surface of the substrate by 2.5%. What does that mean? It's there, it exists. Is it significant? It depends on the elements on the artwork. Alright, that took a long time, and I told you this stuff is ugly, but you see how we can think about things a little bit differently sometimes?